Well, welcome to the panel discussion of day 2 of the Science Symposium. Thanks to all of you who stuck around for this. I think these are really important part of what we want to get out of this conference. And thanks to all of our speakers for a great day of talks and for participating in this. The panel discussion is going to be moderated by Dr. Andrew Paul, who's a member of the SAB, who you saw speak yesterday if you were here. I'm going to go ahead and read his introduction again, and then we'll get started. So Dr. Andrew Paul has been working as an aquatic ecologist in Western Canada for 35 years. His work has encompassed the fields of conservation biology, community restoration, non-native species invasions, population ecology, and river ecology. Andrew uses quantitative methods to aid in understanding ecological patterns or processes and has worked with the Theoretical Population Dynamics Group and the Fisheries Center. Andrew spent 15 years with Alberta Fish and Wildlife studying environmental flows and now works with Alberta's chief scientist to support scientific excellence in government. Andrew is an adjunct professor at the University of Calgary. All right, and welcome Andrew and to the panel.
Thanks very much, Kyle. Yesterday we had a number of presentations that revolved largely around fish, but Kurt's presentation and Nick's and Nate's reminded us of the importance of the connection of fish to the larger ecosystem. Well, today those talks really built, I think, strongly on that theme and really focused on ecological function of rivers, which is pretty exciting. We heard about temperature drift, feeding, physics, amphibians, and reptiles. If yesterday's learning message was that minnows require 300 kilometers or miles, I might have had that wrong, of stream. I think today's lesson, at least for me, is that some of the turtles in this system predate the time of the dam. It's pretty cool. So I encourage folks to come down and use the mic to ask questions. I do have questions that were submitted online. So at any time, come down to the mic. I will start with some of the questions online, but we'll just rotate between the audience and these questions as needed. So the first question, John, this one is for yourself and this morning's first presentation. For a given volume of reservoir release, would modeling predict any gain in forage drift when comparing diurnal fluctuations versus a constant rate of discharge through the day? So have you done any work on that? And I think we're supposed to use the microphone. Yes.
Well, I haven't done any modeling on diurnal fluctuations in flow and drift. I've tried to avoid the diurnal drift because that's not flow related, unless of course you vary the flow during the daytime. So no, I haven't done that. But anything that mobilizes drift from the benthos, so flow, if you increase flows, that's what will happen, and that would increase the carrying capacity, instantaneous carrying capacity. So that would then vary during the daytime. There's quite a bit of literature out there showing how flow fluctuations during the daytime related to hydro peaking, which commonly occurs with hydro schemes, influences drift concentration, drift rates. And some people have thought, well, that provides feeding opportunities for fish when the flow increases and drift starts to increase.
Yeah, thanks, John. Is that diurnal work from hydro operations show that there's sufficient production in the system to support increased mobilization of drift? Is there just enough bugs to be mobilized, or is that lost when you have that diurnal fluctuation?
The papers that I've read haven't gone into that detail, but it would be a concern that if your flows are quite high during the day, that you could start depleting the benthic supply. So yeah.
John, another question for you here. one of the founding concepts of juvenile salmonid habitat on the Trinity River is that there's a dip in habitat availability at moderate discharge. I think that was shown in Derek, your presentation today showed a little dip in habitat at one point. This has been documented on the system and on others using physical habitat metrics like weighted usable area. The base flows on the Trinity River were determined using this information. My question is, do you believe that the use of net rate of energy intake models would change a perception of equity between equal habitat values on either side of that dip in habitat due to in that discharge relationship?
I'm not familiar with that relationship, but I'm guessing it occurs because of the channel shape.
I think it's occurring when you go from the floodplain and lose that floodplain connection into the channel. Yeah.
Yeah. So the second part of the question again about that was?
The question is, do you believe that net rate of energy intake models would change the perception of of potential equity between equal habitat values on either side of that dip? Do you think there'd be any kind of information that NREI could provide from that floodplain production into the main channel?
I think it could. I think the models would work better at the lower flow when you're, so the in-channel flows before it spills over into the floodplain. It would be more difficult to model when the flows are going into the floodplain because it's spread out, and yeah, so I'd be a bit wary about that. But I'm pretty sure that those biogenetics models would give you a better appreciation of how flow is interacting with food and habitat than traditional habitat modeling would.
Derek, this next question's for yourself, and is the total CFS that will be needed for Clear Creek that the Trinity River will supply, is that amount accounted for in the record of decision? I think it's on the bottom.
Trying. So Clear Creek, it's interesting because the watershed above Clear Creek can supply the entire amount of water below Whiskey Town. So that water is already there. Water does come across the come through the car tunnels. Keep Whiskey Town full during the summer, and most of it goes through the Spring Creek tunnel. So the hydrograph that I recommended there doesn't take any more water from the Trinity. That water is already from the low. There's no change there. It's just a rebalancing of how that water is used.
Right. So there would be no requirement for renegotiating or consultation on existing agreements.
You gotta speak like this into it, or we can't hear you.
Full rock star on it. I don't believe so. I think that's already covered. And in the fall, the 50% volume ish that comes over from the Trinity, they could some years bring 600, 700, 800,000 acre feet over on certain years. And like I mentioned in my presentation, Clear Creek is using about 155 total. So a very small fraction of that. And again, the upper Clear Creek is providing probably the majority of that water, except during the critical timeframes in the fall or the summer and the fall.
Well, maybe I'll keep you on the hook here with another question for yourself now that you figured out the mic on. Your recommendation is for channel restriction to be 200 CFS. Can you talk about or explain how this recommendation affects not just the salmon, but the whole stream and ecotone communities?
Yeah, absolutely. So right now, unfortunately, the money and the time that we've invested in building this floodplain, this 2.2 mile stretch, is effectively barren. Other than the riparian berms, which are very thick, if as soon as you get out onto the floodplain, it's dry as a bone. So what I'd hope will happen, and I want to have two examples, beavers and chironomids, as examples. So I have seen beavers on Clear Creek, and there's a very robust population of beavers on Clear Creek already. They've tried to make channel spanning dams, but because the channel morphology is, the channel's so big and it confines all the water down to a narrow area, as soon as flows come up a little bit, it gets super fast and blows their dam out, right? So if we can get a more multi-thread channel where the power of the water is spread out, and then there's roughness elements that they can play against, I'm hoping that they can make dams, create habitat for us, right? They're ecosystem engineers. So on that, for beavers, I think it could be really great. But then for chironomids too, I maybe I should think of myself, and this is a term that I think Kyle gave to me one time, but we are free range aquaculturists, right? And to do that, we need to produce food. So how do we bloom chironomids across a much larger area? So flood areas that are normally dry, get them up, get this vegetation decaying so that all these things can happen and you can get this bloom of chironomids and over a huge area, and all of this makes fish feed. So maybe I should think of myself more as I should get more into chironomids and be a chironomid biologist, because that's really that's what I need for my fish.
Yeah, thanks, Derek. Same thing crossed my mind as well today. Todd, this question for yourself. I probably missed the information on a previous slide, but how deep was the UT pool that you discussed? And also, how deep does a pool need to be to experience a temperature stratification cycle?
The UT pool was 5 meters deep. What's the minimum depth that would support stratification? I don't know, but I'm going to learn in the extension of that study across all deep pools in the restoration reach. Daniele Tonina has been working on stratification pools, and it sounds like a greater diversity of pools than I presented today. Daniele, would you have a guess on that? So which river is that again? Grand Ronde, awesome. So in the Grand Ronde, Oregon, minimum depth for stratification, Daniele Tonina found was around 1.5 meters.
Great, thank you.
At what flow? Around 30, at a flow to around 30 cubic feet per second.
Keep the mic there, Todd. At the flows that would enable pools to stratify, how connected would the river be between pools? Are there sections that would go subsurface at those flows if you look at the hydraulic modeling runs of those discharges?
Yeah, we'll find out. I doubt it. If it did, it wouldn't be in a natural situation that happened on the pre-dam Trinity. It wouldn't be something that would be probably supported by management actions here. Mostly recreation would be, of course, disallowed by a disconnected river. Boats can't float across dry gravel bars very well. So how that stratification flow for the restoration reach gets derived will take into account other needs of the ecosystem, fish, people, stratification, temperature regimes, bugs, all these things. So that's a work in progress, but it's not my expectation that the discharge that stratifies enough pool volume to provide the escapement goal, spring chinook, the habitat they require in the holding season in summer would lead to a disconnected river.
And Todd, this question was associated with yourself as well, but I'm going to open it up to yourself and everyone. And this was, What changes do you envision would need to be made to fishing regulations if this flow regime was enacted to not overharvest spring Chinook? But I'll pose that to everyone, given some of the flow regimes suggested. Would there need to be other regulatory changes needed to match those flow changes?
Yeah, I'll take a stab at that first. That's kind of a cool question. Well, the fish are in the reach, whether the pool's stratified or not. So I guess the asker is expecting that the fish would be easier to catch in the stratified pool situation. I don't know why that would be the case. In fact, they could be harder to catch because the flow would be more placid. The fish could see better because turbulence isn't blocking their view. And so harder to catch the fish. More fish survive the fishing season. I don't fish the Trinity, so that's my logic, and it could be flawed. But if someone else wants to take a stab.
I mean, the state has low flow closures for fishing on other rivers, and if it was found that flows that were low enough to stratify the pools made the spring run Chinook more vulnerable to fishing, I think that's a management problem that is surmountable and could be overcome with some type of low flow closure, something like that, if deemed necessary.
James, are you ready to go there?
Yeah, thanks, Andy. So this question, it's kind of inspired by Todd's presentation, but I think, there's plenty of fisheries expertise up here to answer. But Todd, you mentioned, you kind of touched on the energetic demands of the current summer flow schedule. Mentioned like a meter per second, and springers are holding against that current, using energy that would normally go towards gamete development or later on in spawning. But I wonder if there's more to it, and that's in a stratified pool, springers would be able to select the optimal temperature range for gamete development and not have to, even if they would, I don't even know if they would think about doing it, but otherwise they'd have to move long distance laterally to make that selection. I'm wondering if somebody has something to say about the importance of gamete development while springers are holding, and how that would maybe affect spawn timing, especially relative to the heterozygous Chinook in the system, and if that's something that should be considered in your future work on this, Todd.
Yeah, well, Ken, is that Ken? Yeah, standing right behind you. Is probably the best person to answer that question in a sense, because I believe CDFW has some information on the overly cold summer flow effects on gamete development and salmon that return to the Trinity River. My take or angle on that type of question is more the reduction in fitness, because those poor fish are swimming against that fast water all summer. There's very little slow water refuge for springers in the Trinity River in summer. But you go to somewhere like the Salmon River where you got naturally low summer base flows, and there's these, or even the North Fork Trinity River, hike up the trail there and see these natural flow regimes, these stratified pools, and the fish are just laying around like cordwood in the bottom of big pools. And that looks pretty relaxing, as opposed to fighting the current in the fast and cold Trinity River. So I would logically surmise that those fish in the natural flow systems are retaining energy that could be used in terms of body size to build more effective reds. And what effect it had on the gametes, I would expect that there would be more energy put towards egg development. And then I'd have to go to a fish biologist for anything more on that. Okay. Also want to add to that.
There. Gamete development is one thing inside the female, but something that I want to point out about gametes or eggs on Clear Creek that I think people might find interesting is that we have spring run Chinook salmon fry swimming in Clear Creek in October. So think about that. And I think it's all dependent on water temperature. Our water temperatures are considerably warmer than the Trinity. And so those fry are up and at them pretty quickly because their development is so fast. I think that little bit of time advantage is really important for those spring run because as soon as they go below the gorge, as soon as they get out to the sack, they're going to be swarmed by their brothers and sisters. So getting up quick and starting to feed and starting to grow before everyone else, I think, is an advantage.
Thank you. Ken, go ahead.
I just had one quick comment first. So Todd, is there any plans to do any, I don't know what it would be called, bioenergetics modeling or something like that, or development modeling of the adults in the pools? That seems like it would be a good idea. If
Not
it's
by
easy,
me.
it's possible to do.
It could be, I've worked with a number of people on this project, and Kyle or the Fisheries, and they might take that on. Right now, it's not planned. We're more going towards that habitat, what volume of habitat is produced at a given time of year and flow in the pool habitats in the river. And then we're going to expand those, the effects of those types of flow regimes that meet those escapement goals for holding, or the holding habitat for the escapement goals, and start to see what the effect of this type of revised summer flow regime would have on a number of critters. And you just suggested another thing that we could look at, but it hasn't been explicitly considered yet.
Okay, thanks. I think this is a question for John. Most of your presentation was focused on drift, and I know that was just a small subset of the work that you've done in your career. And obviously drift comes from the benthos, right? And so the benthos serves as the source for the drift. And the literature is kind of mixed on the relationship between benthic biomass and biomass in the drift. Could you just provide your thoughts on what that relationship is like, and if there's any work that has been done to link those two in a meaningful way?
Well, I showed one relationship between benthic biomass and drift biomass from the Columbia system. I've seen others out there as well. I haven't explored that very deeply, other than looking at in the literature, and there's enough evidence out there to show that the two are linked. So is that what you were wanting to know?
Yeah, I mean, I know they're linked, but I mean, there has been some literature that showed no relationship as well, which is kind of nonsensical, but you know, we're kind of going down that direction in the program, trying to get a better understanding of productivity in the system and like how we might be able to affect that with flow management. And my thinking at this point is to focus first on the productivity side, not the drift. Obviously, drift is the most important thing ultimately, but drift doesn't help us with making just more food generally in the system. And so there's something that you know, that bridge needs to be gapped, or that gap needs to be bridged in order to get us to how does increasing productivity in the system through flow management then translate to getting more fish, right? So there's a and in a model that might get us from flow to how much food is in the drift. It seems kind of odd to just skip a good understanding of how flow affects benthos. And so I'm just trying to kind of think through how all those pieces might be linked.
Yeah, well, I've talked to Eric Peterson about this. There are process-based models out there that I've been involved with, and they are coded up that can predict how flow will affect benthos, the benthic invertebrates, but also periphyton, as a function of flow disturbance, scour and desiccation on the margins. So you can do that. But following up on your drift question, I think this is where you are going, and it's a very good idea, given that there are some conflicting information from the literature about the relationship between drift and the benthos. You need to provide that scientific justification in the Trinity. So I think that is where you're going. It's a good idea. I'll be surprised if you don't find a relationship between drift density and benthic density or biomass. The other thing I noticed when I got into this area is that some of the drift studies haven't been done very well. People just recording rates and not concentration. So I think some people didn't quite know what they were doing. So, and then there are other things that affect the relationship, flow variability during the daytime. So you just need to be able to control for some of those things.
Yeah. Thanks. We want to not get it wrong. So we're leaning on you, I'm sure.
Yeah, just following up from the first question that Andy directed to me, I think my brain's been sort of processing that since then. And that was around the habitat flow relationships for juvenile salmon, and it has a bit of a kink in it across the flow range model. One of the big benefits in applying bioenergetics modelling in that case would be that you could construct the equivalent of habitat suitability models based on NREI for different temperatures. So I don't know what the habitat suitability models were that were used in the habitat modelling that was conducted on the Trinity. But I do know, as I said in my talk, that they can be very subject to bias. It's very difficult to get habitat suitability criteria that are free from bias, even if you do try to correct for habitat availability bias. And the good thing about the energetics approach is that it skips that. And for each combination of temperature and drift food supply, you can construct the equivalent of different habitat suitability models. That bioenergetics HSC model that I touched on at the end of my talk does that. And the other thing I think you might find is that if you did apply a bioenergetics approach to the juvenile salmon, you might well find that they are able to make a living in faster water than you thought they could, just based on traditional habitat modelling.
Thank you, John. Michael?
Yeah, I think this could probably go to almost anybody because it sort of crosses the various talks that we had today. But, you know, there's been a lot of comparison of the Trinity in its regulated and unregulated state to other systems. So like the South Fork is much more productive for herpetofauna, as are the unregulated tribs above the dam. And the Trinity in its unregulated state is very, very similar to the Salmon River. But the South Fork Trinity River has in the tens of spring Chinook returning this past year. And you know, in a good year, the Salmon River, which is considered a stronghold for wild spring Chinook in the Klamath Basin, has hundreds in the entire river. I mean, to the extent that the snorkel surveyors physically cry sometimes at the conclusion of surveys. So I guess my question is, in a shifting climate and with the knowledge of how these unregulated rivers are faring as it relates to spring Chinook in particular, are we sure that emulating the hydrology of those systems is really the right target? And I'm very obviously asking this as a devil's advocate.
Well, yeah, I personally would not, I would never advocate for blindly emulating other river systems for the reasons that you mentioned. I have a I have a graph on my presentation of the coefficient of variation of the Salmon River, which also after about 1950 became much more variable. And so I think when we are developing new flow prescriptions, we need to keep those things in mind. We don't want to throw the baby out with the bathwater. We want to figure out what's working well now and what we can do better. You know, for example, we know that our flows are too cold for optimal juvenile growth in the spring. So that's something out of our hydrograph that we can target to do better by. However, I think I was talking with John Buffington about this. I don't think that climate change is a good reason to not attempt to emulate local hydrology to some degree. And, you know, also like the example from Deadwood Creek, you know, you're never going to solve that problem without synchronizing your dam releases with local hydrology. And that example for Deadwood Creek, you know, fire patterns are getting worse. That problem is going to only get worse. And so, yeah, I think we need to pay attention to the constraints that climate change is putting on all of the biota and all of the river systems around. But yet we should still try to, we know we can do better than we're doing now. And that's what I would recommend.
I think one thing on the climate change and emulating the thermal regimes or hydrology of other local rivers would be, to the extent that we have modeling tools that can simulate things, and we think we have some understanding of, so we can simulate sort of the physical processes, the physics, the temperature, all that, velocities. And then if we think we understand what the fish response would be, I think it would be important to do, like for things like the stratification, to do some kind of like stress test. Well, what if we get, you know, look at the worst meteorological conditions that we've seen in the past century. Maybe it was 115 degrees for 3 days in a row or something like that. Run that with, you know, various dam release flow scenarios, and including ones that are low enough to promote stratification, and see which one, how they performed in those really extreme conditions. And then try to anticipate, well, maybe we'll have 3 days in a row of 120 degrees. And then, you know, what happens then with future scenarios. So that's a good part about having these tools developed, is we can sort of try to make some guesses about the future. And so I think I like what Seth said about using the other streams as sort of context, but not following them blindly. And so, but using them as guides to see, well, the Salmon River is like this, but what if the Trinity was like this? What effect would that have on these different things that we care about?
Thank you.
Thanks, Michael. Go ahead, John.
So this is a question for John. When you were talking about the drift characteristics with discharge, it got me thinking about sediment transport characteristics. And you showed that the concentration of drift goes up with discharge. And we know in sediment transport, not only does the amount of sediment increase with discharge, but the size of particles that can be entrained. So I was wondering if you'd looked at the size of the bugs being entrained, and if that, you know, is more nutritious at higher flows.
I'm glad you asked that question, because there's a good story I can tell about it, about reinventing the wheel. So when I got into this subject of drift concentration and flow, I said in my talk that it was a eureka moment to find that drift concentration declined as the flow went down in the first study river that we looked at. It's like, hey, this is a great discovery. No one else has found out about this. And then after all of that modeling, quite a few years down the track, I was cleaning out my office when I was retiring, and I came across a Ph.D., a doctoral dissertation that I had a photocopy of. And I knew about the paper from that I'd read by that PhD candidate and a supervisor that had shown that drift declined as the flow went down. And when you got to an average water velocity of 0.3 meters a second in their study river, that drift had dropped out and brown trout switched from drift feeding to benthic foraging. And I thought, okay, that's right. That's great. I remember that. But what I did not remember, and I think I must have skimmed over it when I first got the PhD, was all of the research that had been done in addition to that, including the very thing you're asking. And they found that PhD candidate found very clear evidence for the large invertebrates dropping out first as the flow went down, as you would expect from sediment transport theory. And they are, as the fish get bigger, they want bigger and bigger prey items. And so that's the very thing that they're wanting, and it's falling out of suspension. So I realized at that point I'd reinvented the wheel, and that if I'd read more carefully and had a better memory, I could have saved myself a bit of effort. But the other thing about that was that it demonstrated to me why discoveries made at some point in time don't necessarily have the impact that they should have. Now, I know that those two researchers, the supervisor and the PhD candidate, were doing the research because they were concerned about flow effects on trout populations. But it didn't really have a big effect. And I think the reason for that was because they didn't have predictive models at the time. They didn't have hydraulic habitat modeling that they could have launched off. And that makes a difference. You can see in a lot of the talks that when you can show these plan diagrams of where fish should be, or heat maps of various things you're throwing on the screen, including, in my case, predictive fish numbers, that has a compelling effect on people. And I think that's what they were missing. So it's the alignment of knowledge with technology can make a big difference.
So one follow-up, does your model account for the size of the bugs at different flows?
Oh, yes, it does.
Okay.
Yeah.
Okay, so that's part of the energy balance.
Yes, it is.
And then, fish are smart. So as the flows drop, are the fish changing from drift feeding to benthic feeding?
No, we haven't got that in there at the moment. Yeah. And I was asked that question earlier. Mike Dodrell asked me today, how do I defend that point, when I'm in environment court hearings? And I always get people to focus, again, look, it's flow that we're trying to manage. Look at the flow critical fish and the flow critical behaviours of those fish. And large fish and drift feeding are the flow critical things. So the switch to benthic foraging occurs at much lower flows, and by that stage you've already affected drift feeding. And if benthic foraging was so important, then why at higher flows don't most of the fish do that? They preferentially drift feed. Some decide to do something different, and Kurt was telling me today about some fish that like to just feed on the surface. So there are individual things going on, but it's drift feeding they prefer when they've got the flows available to do it.
Thank you.
Can I just put you on the hot spot a little bit more there, John? So did that just do a disservice to anyone working in a turbid stream that doesn't have drift feeding fish?
No. And again, Mike, it's quite prescient. He asked that question today too over lunch. No, you did it entirely different there. And so there you would have to consider benthic foraging, other means of foraging. Yeah. And you could show with drift foraging energetics models that drift feeding was unprofitable because of water clarity in those situations.
Sorry, go ahead.
It's all right. I'm gonna ask John a question too. You mentioned that Chinook, when they were introduced, it seemed to be viewed very positively. But you also talked about a couple of species of trout, and you referred to them as being invasive. And kind of, you hear a lot of case studies where a species introduced and then it caused a lot of problems. So I was curious, what the difference was between those introductions and if there's like something we could learn where the Chinook had a more positive introduction than the trout.
Again, we were talking about this over lunch, and it's the coming to grips by society with the values of introduced species and native species as well. And in New Zealand, we've gone down the track more in the last 2 decades or so of what I call Indigenous conservation ideology, quite strongly affecting how people view introduced things. And it comes in New Zealand, it's been driven by the devastating effects that mustelids had on our bird fauna and a brush-tailed possum from Australia, and also rats, just devastating the bird fauna and affecting the terrestrial flora as well. And so when a person is focusing on that and then looks at the freshwater environment, the natural tendency is to think these introduced salmonids are really bad, so they're the equivalent of a freshwater stoat, for example. And while it's true that those fish have had some quite serious adverse impacts, they have, as I showed in my slides, some very positive benefits to people. So in New Zealand, mustelids, I can't think of any good thing that you could attribute to mustelids. Everything's bad, seriously bad. But for trout and salmon, there are some real positives, and including for salmon, a significant aquaculture industry. So how do you balance those things, positives and negatives, while also trying to protect or conserve native fauna? And New Zealand isn't there yet. I don't think there's a mature debate or a mature way of looking at that yet. It's sort of the pendulum swing. It went from New Zealand when salmonids were first introduced. They were the favoured species, and people who were introducing them and trying to spread them more widely rode roughshod over the concerns of Maori and even Europeans who were saying, "Hey, this isn't a good thing." And now and also there were even bounties on eels. So people were going out and killing eels because they ate trout. Craziness, yeah, and that's a great insult to Maori. That was they call it the taonga species, the treasured species. So we've gone from one side of the pendulum now swinging to the other, and the balance is somewhere in between. So it's a long way of getting to your question. So brown trout have had the biggest impact across our country on native fish and including on invertebrates. And we have some real problems with fragmentation of some of the non-migratory galaxid species. These are native fish. And brown trout have been, they've been implicated, and they are the cause of that fragmentation, competition and particularly predation. And so you get remnant populations of those galaxids above falls. Similar sort of issues that what Kurt was talking about in his talk. So now the conservation interest is to try and preserve those remnant species. So most native fish in New Zealand are cryptic. They're small. No one knows about them unless you electric fish them, and there's some beautiful fish that you can see. So they become important when they become rare. So if you want to get attention, become rare, essentially. And so that's what's going on. Trout have had a big impact, brown trout in particular, rainbow trout a bit less so, but still also an impact. The salmon, I can't think of any real negative effect. No one's looked at that seriously with salmon because where salmon are, trout are too. But the good thing about salmon is that they come into the river, lay their eggs, grow juveniles to about that side, and then they're off to the ocean. No one knows what's going on in the ocean. So that's just a black box. But there's all just positive effects, positive benefits back to people. So that's a very long way of answering your question. Does that answer it?
Yeah, no, I was like kind of looking for the long answer because I was curious to learn about it, but thank you.
Yeah.
Thanks for asking that question. I'm sure it was in all of our minds. I guess anyone that wasn't at lunch with you. Next question is for Eli and Don, but I'm going to open it up to everyone again. So this is, we are building understanding of how temperatures impact juvenile salmonids on both the cold and warm sides. How about the temperature effects on benthic macroinvertebrates, periphyton, amphibians, reptiles, other species?
Start off by saying I'm not a fish biologist or an invertebrate biologist. And we are starting to look at algae, but haven't really even got that study underway. And because the different types of algae have different nutritional value for the tadpoles, we're going to try to look at that. But no, mostly we have just been looking at the size and condition of the animals themselves. With the turtles, we didn't really see that they were resource deprived at all. With the tadpoles, again, we don't think it's a resource depravity, but rather the growth being influenced by temperature. But yeah, I don't know how the temperature is in fact impacting the algae or the bugs.
I guess I would say to that every organism has a range of things conditions it can tolerate, and then conditions that it really likes and thrives under, and that it is theoretically possible to study those things. I mean, people have done experiments with algae, with the periphyton, where they go somewhere and they do like a mixing where you have like these different flumes, and each one of them is 1 degree Celsius difference, and you just leave them out there for a year or something and see like what algae grows in there. And yes, you do find different algae at different temperatures. And I think there's been some lab experiments too with invertebrates, see what temperatures they like and what their reproductive rates are and all that kind of stuff. So I think it's possible. I don't think there's been a whole lot of work done in the Trinity, but we did a little bit like with the stuff I showed of the development rates of the midges and mayflies.
I can add to that in that paper on stratification that we published looks at the effect of the temperatures that we experience in the restoration reach at the temperature compliance point at Douglas City compared to the rate of macroinvertebrate production. And at the current low temperatures, the production is suppressed by, it looks like, around half. And so if we were to increase the temperature, summer temperature in the restoration reach, we would have more food for the juveniles, and then the temperature benefits to the juveniles as well.
We found the same thing in the temperature synthesis with you showed the graph of the beta day generation time, and essentially with really cold releases from the dam in the spring, we're substantially increasing the generation time for some of those invertebrates. And so, yeah, like what Todd said, basically producing less food. And then you couple that with static low winter flows that don't scour and reset the bed at the right time of year. And then those really small mayflies, midges, and other first colonizers after a scour aren't really able to aren't really able to populate the water column or the benthos at the right time for fry to eat them. It's a double whammy.
Mike, go ahead.
I got two questions. The first is a little bit of a problem statement, and that is there's a lot of discussion over the last couple of days about the cold water and the so-called detrimental cold water. And I'd like to point out that when the record of decision was being developed in the late 90s. The flow study said earlier is a joint Fish and Wildlife Service and Hoopa Valley Tribe, a joint published document. But in the run up to the completion of the record of decision, we had the policy and legal people all in the same room. And what it did was, if there was an issue there that needed to be explored, there was a data gap or something, there was a legal and policy people there to answer the question right at the time. But what I wanted to say with that is, in that case, the whole time frame for releasing water was October 1 through April 1 was off limits. That was what the statement was. So related to that, and that little bit of clarification there, for probably Eli and probably Seth there, in your guys' report, you allude to the temperature control device, which I think is a good thing. You know, the temperature change in the reservoir. How much would, if you added a temperature control device and or carryover storage is another one that was off limits. Either of those, one's a management action, one's a technical methodology or technological fix. Would any of those alleviate the so-called cold water problem?
So there was a little bit of work in the 70s that I think it was 1978. Rowell was the lead author. There was a reclamation study that they looked at potential for multi-level release, but I think they were looking at it more of, could we use it to make the water, was it to make the water even colder? Was that what they looked at? And I think they found that it would be helpful that much.
I think there's a 2012 one more recent, what we'd call the appraisal analysis too. I think those are kind of looking at some of the similar fixes to that, being able to move the water through Lewiston.
Yeah, on Lewiston, yes, in 2012. Yeah. So I think I think there should be some additional work on the temperature control device. So one thing would just be like looking at the volumes of water that are there. I mean, I think the good thing is that I would think from an intuitive perspective, if you're drawing off the surface warm layer as we're going into the summer, you're not going to like deplete that surface warm layer. It's going to be sort of renewing itself, right? It's like if you're drawing from the cold water, you're not getting any new cold water, you know, as you go through the summer, things are warming. So I would think that there should be, you know, the warm water available in the surface of the reservoir to use, but it would be worth, you know, doing some math on that and just sort of seeing if it works out. And then I have no idea I don't know that any, you know, infrastructure engineers who know about this kind of stuff, like, do we know, no one's looked at it, like, how do you take an earthen fills dam and put a temperature control device in it? And I mean, it may or may not be possible, but it should be looked at, yeah.
And the second part of it was carryover storage, which is something that was precluded as well, because the diversions are over a 3 or 4 year period often,
right?
Not just on the annual basis like the rod flows are, the fishery releases.
Yeah, I mean, definitely that was one of the recommendations in our report, was that carryover storage is important, and it's kind of crazy in a way to just look at every year in isolation and not look at it in the context of what happened here before and what might happen in the next year. So I definitely think that's something that should be looked at. I have no idea on the legal issues about it.
I was just going to say, I think Cougar Reservoir in Oregon, we were talking about that just before. I think there is a temperature control device, and I think it is earthen fill, concrete. On Billy Chinook, on Lake Billy Chinook, there's potentially. I mean, I have some ideas of how you would do it, but I'm a fish biologist and I'm not an engineer, so I don't know if my ideas are any good. But I think it'd be a challenge. But I think moving into the future, it's, we got to do the studies to begin to understand it, begin to understand the costs and the trade-offs, and without doing an appraisal study and then doing a feasibility study, we're just going to be stuck having these conversations about what it will be like.
And it's worth noting that the TMC has repeatedly on a number of letters requested that next step which is a feasibility study.
Yeah, and then on the Lewiston temperatures using reservoir management to help manage temperatures released to the river. Derek, me, and Chris Listoki are studying that now. There's going to be some results coming out in the next couple of years that will help inform some kind of assessment on whether or not that would be possible and beneficial to the river. But I would point out that even if you could release let's say the right temperature out of Lewiston at the 450, you're still shoehorned by the high velocities in the pools at least. So it's not just a temperature thing, it's other things too, but
okay, well, I got the next one. My next one is the whole spring Chinook thing. And I think you just raised your hood up on a lot of things relative to the regulatory process under the Endangered Species Act. And we have one listed species presently, and it creates a lot of rigidity, a lack of flexibility. But I'm not the petitioner for the spring run Chinook, but the regulatory agency is still sitting on that. And I think that needs to be resolved at some level. Secondarily, when and how that's resolved, conservation standards need to be set and developed. And there are a lot of work that's already been done in that regard. But that's one where, and then when you look to the program, it becomes a money issue here. I'm going to use an example, and I'm probably going to use it wrongly. The $31 million that got used over there and Whisk, a tributary that probably wasn't much there as far as a fish producing stream until the diversion of Trinity River water. But the potential there for some of that stuff to be utilized on this side. In our basin, we've often run into a situation where we don't have enough money to research something. But in the case of the spring run Chinook, we are regularly meeting the goals of the program, and they're pre-dam level numbers that are published information there. So sort of my question that emerges from that is what's broke there that needs to be fixed for spring run. Thank you.
Someone want to respond to that, or?
Yeah, I would surmise that the goal may be too low if we're meeting it under suboptimal conditions in the river. If 9,000 fish are, and I don't track fish numbers, but if 9,000 fish are making it back, if we were to implement a more beneficial flow regime and temperature regime, how nice would it be to have 3 times that? There's possibilities here that are untapped.
I mean, one thing that, could be done to improve it is to continue to improve the floodplain habitat and just create more options for the spring Chinook so they're not all stuck in the single main channel. That's going to help regardless of what happens with flow releases or temperature control or any of that.
Thanks, guys. Go ahead.
Don't know where to start with this one. I got some thoughts swirling in my head. I really think it was a missed opportunity by Reclamation to try to pursue at least a appraisal level study for a temperature control structure. Somehow they identified $60 million for the hatchery, which I'm sure was very much needed, but they always say bill and IRA funding is a once in a generation opportunity. I think you look at our federal deficit, and the likelihood of having that kind of money available again for a high dollar project like a temperature control structure is pretty unlikely, at least in our careers. And so I'm feeling rather bleak about any future opportunity to add a device like that at the dollar value that it would require. And then I think about the public acrimony around the program. They find ways to hate the program at almost every angle, or at least a very small subset, but very vocal subset of people that live in the county or that fish on the river. But probably what they dislike the most is the flow releases. given now what we know about the effects it has on juvenile salmon growth, the effects that these spring releases are having on turtles and frogs and other cold-blooded creatures that use the river, I wonder at what point, especially in larger water years, with your inability to shift the timing of flows and all these other compounding factors, especially in larger water years, does this water volume that the Hoopa Valley tribe in the hard-fought battle that they did over several years to get this water back to the Trinity, does it begin to feel like a liability when it becomes time for flow planning?
In the absence of winter flows, I think you nailed it. Look at our hydrograph this year. We know that releasing this much water this late is not a good thing, but we have to use the water because it's the allocated volume that we are to spend in this water year, this wet water year type. If we had the ability to release the winter flows that you published on with your co-authors, we would start to see much greater benefits, and that water would become a comparative blessing because of the benefits that would come from the release being for the reasons that we have scientifically validated and proposed and not yet been able to implement. So overall, more water is better, but we need less restrictions on how to use it if we want to use that water to the benefit of the ecosystem.
Yeah, I would say overall, it's definitely the longer this goes on, where we don't release flows in the winter, the more and more of a liability it becomes. And, as we've shown, a bunch of people have shown, we know that we have ways and tools in our toolbox to minimize the effects of the Trinity River Division of the Central Valley Project on species, and we're not using them. So that's, it's not a good look, and it's not good for the species. So yeah, I'm hopeful that this year that the powers that be, Reclamation, others get the memo that we need to start releasing water in the winter. And I think I'm optimistic one way or another, we're going to get there. I don't have any doubt in my mind about that. How exactly it's going to play out. We have a new consultation coming up, and the method that we showed today that Nick and I have been working on, as well as the method that Kyle and you and Ken and others, Justin Alvarez, and a different method to release water in the winter. They're alternatives in a NEPA planning document. So I'm very hopeful that we'll get there. But yeah, we need to start in earnest. And it's really, I mean, for me, it's a shame that we didn't do that this year. I mean, it's as a mark against the program, well, not really the program, but the other decision makers or whatever. It's we know we can do better.
Go ahead.
Can I add a little comment to that for as well, and just kind of back to the recorded decision and the flow study that preceded that. That was an improvement over what had been done prior to that. And I think that people writing those documents were working with the best available science. But that was 25 years ago, and we have learned a lot more. And adaptive management is a keystone of this program. And we're meeting specifically at this symposium to think about paradigm shifts. And so I think in light of the presentations that we've heard in the last 2 days at least, maybe it is time for serious reevaluation of some of what we have been doing with the record of decision. And again, in defense of it, it was a big improvement. It's nice to see that variability amongst the different years, and we're just not done there. We need to keep moving, keep learning as we learn more and more about the system.
So I have a question for Eli. In your talk, you had talked about how smoke has some cooling effects on the water temperature, and I was wondering how you quantified smoke for looking at that.
Yeah, that's a good question, sir. Those specific studies, essentially using remote sensing. So the MODIS, Aqua and Terra satellites from NASA, they fly over about once a day. Towards the middle of the day, I think one's like 11 a.m. and the other's 1 p.m. or something like that. So it's not the full diurnal smoke blowing around everywhere at different times of day, but at least gives you a representation of this day. There was a lot of smoke, but there was no smoke. So it's essentially looking at the they call aerosol optical thickness. So if you look at the satellite imagery and you can see the ground perfectly underneath, then that's an optical thickness of 0. If all you see is just the smoke plume and you cannot see anything on the ground, that's like a 4. So it's just kind of on this arbitrary 1 to 4 scale. So that's what we used. And I think we did a little bit of we did it different ways. We did some where we calculated the total smoke in the watershed upstream, and some we did just like a several kilometer buffer just around there. So with remote sensing, because the smoke, I mean, you probably know that the smoke, it could be really smoky one place and not very smoky just a few miles away. You can't just really rely on like an air quality sensor on the courthouse or something like that to represent the whole river or the whole county, so the satellites. And there are some new satellites, the newer weather satellites, it's GOES. I don't know if it's pronounced GOES or GOES or however you say it, that launched, I think, at 18 or something like that. It has the same sensors that can get that aerosol thickness every 15 minutes. I mean, it's kind of the most insane data processing exercise you can imagine to try to summarize smoke every 15 minutes. But there is more data out there that if we really wanted to look at that. The settling on versions at night and then blowing off in the afternoon. So, yeah.
Well, thank you.
Yeah.
Thank you. I guess maybe I get to ask a question too. So, John, you talked about drift feeding fishes and the NREI model and how predictions from that actually might say, well, optimal flows for salmonids for feeding actually might be higher than some of the habitat suitability curves. So maybe a higher flow than we looked at before. Todd, your presentation was looking at stratification in pools and looking at, well, we kind of need subcritical flows to make sure we get that layering happening. Eli, you looked at temperature relationships with flow as well. And Derek, you had a oscillating pattern into yours, introduced that intra-annual variability just with a simple sine wave to start. All of these are different predictions on I'll use the term optimal flow regime. They may not all align. John's might be different than yours, Todd. That might be different than Eli's or Don's or Derek's. Any comment, and this is of course open to the whole panel, any comments on how you would see kind of layering these things together and coming up with a ecologically functional flow out of all of these different recommendations?
The program has several times considered going down the path of turn taking in flow regime designed for different species and considerations, and we haven't gotten there. We haven't developed that. But that would be one concept we could use to combine all the potential good, and remember that the variability in flows can be so great naturally in basins that the turn taking occurs naturally in unregulated basins. So in a regulated system where we have our hands on the knobs, it's going to take more work, like has been presented today, to understand the system well enough to know what effect you might have by your flow prescription on the species that you can account for. And I think we're headed in that direction. I think we're getting darn close. We got a lot of work to do, but we're getting closer.
Comments from anyone else?
I briefly touched on that, I think on one of my end slides, just pointing out that, we don't expect every year to be a good year for the frogs or every year to be a good year for the turtles, but they have long enough lifespans that, as long as we give them, give them years that are going to be most beneficial to them and really think about management for them in those years. For example, prioritizing foothill yellow-legged frogs in drier years where maybe it's not as good of a year for fish. And I don't know about what are the good years for fish or not. But, you could really weight how much management effort you put towards individual species based on what you might expect from them in a natural system anyway during those years. With the foothill yellow-legged frog, for example, they're not going to do as well in the main channel during wetter year because naturally you would have those higher flows later in the year, the lower water temperatures. But those are the years where they do better in the smaller tributaries because those little tributaries don't dry out as quick. But in the dry years then, where you're going to let the production of the frogs occur better in the main channel, those are the years where the tributaries are going to dry up sooner, and so those populations won't thrive in the dry year, and so you really sort of have this sink source dynamics, and we really see that playing out when we just look at the distribution pattern. I know I didn't cover that in my talk today, but the populations are doing the best near tributaries where this sink source dynamic between the tributaries and the main stem can function.
Derek, I have a question here for you. The changes you've proposed to Clear Creek flow management have provided a bankful target for the channel morphology of Clear Creek. How has that impacted the other actions such as channel rehabilitation and gravel augmentation that you're performing for restoration purposes?
So I would kind of flip that a little bit. It is those other things that will get us to a bankful of 200, right? It's the continued gravel augmentation, maybe sped up a bit. It's the continued introduction of boulders and large wood that'll add that complexity, that roughness that'll get us to that 200 CFS bankful. And also, it's not everywhere that you would go for that target. There's a 10-mile long canyon. We're not going to change much there. It's a canyon. It's bedrock confined. It's very narrow. You're not changing much there. It's in these alluvial spots with really large, wide valleys, a lot of process space that we can push that forward. So in terms of channel rehabilitation, I think that the restoration reach we completed is done. The terminology I use is there was a revolution to change that stretch, and now it's more of an evolution, changing it. The big whopper of the project's done. Now a lot of little continual projects to keep it going. I hope that answered the question.
John, I've got a question for you. Large salmon runs bring marine nutrients upriver and could have made it for a much more nutrient-rich system, pushing a mesotrophic system perhaps towards a eutrophic. Currently, the Trinity River looks mesotrophic at the foot of Lewiston Dam, but becomes nutrient poor or oligotrophic within a few miles. Is our river starved? And if we get salmon production back, should we expect more paraphyte and more benthic macroinvertebrates? Is there a chicken and an egg challenge of needing nutrients for salmon, but needing salmon for nutrients?
Yeah, well, that's a well-known issue about nutrient importation. I would have thought that a critical factor here, though, is temperature. If the temperatures are too cold, the juvenile salmon aren't going to be able to make the most of any nutrient enrichment that you've got that you make anyway by more returning adults. So I think you've got to solve that one first. Can I just raise another question of my own?
Certainly.
It's actually directed to Todd. Did I hear you correctly when you were looking at stratification in pools that a flow of 30 CFS was what you arrived at?
Are you talking the PT pool, the bigger pool?
Oh, I've forgotten, but just that figure of 30 CFS came in my head for some reason.
Yeah.
Was that right?
Yeah, that was Daniel's pool.
Okay, so what was the flow that you came up with for encouraging stratification? And because you had the idea that the adult salmon would be able to migrate at night.
Yeah. CFS stratification flow at the larger pool on the restoration reach. And the upper pool, the observed stratification was 15 CFS.
The question that I was going to ask is, I don't know enough about the river, of course, so this might be a fairly naive question, but if you're thinking that the adult salmon would migrate at night under those flows, they seem fairly low to me, those flows. So is there anything known about that adult salmon passage and whether that might disrupt them?
Yeah, we would look at that for sure. Summer flow change. But James Lee, he just walked out, unfortunately. He's going to talk about that summer base flow effects on riparian vegetation. And I'm going to put my foot in my mouth a little bit, but I'm going to go on a limb anyway and say that if we were to lower that summer base flow, get the veg to grow in on the channel to produce a more complex channel, more roughness, you would have wider variability in channel sizes moving longitudinally in the system. And so instead of just one channel with whatever flow in it doing whatever it's going to do based on the channel dimensions, you might have multiple channels because of this vegetation complexity, enabling different depths and velocities in different parts of the channel to help aid migration at a lower discharge. That is thinking, I believe. But whether or not 70 CFS would allow passage in the contemporary channel, my gut is it would.
And feel free, panel members, to ask other panel members questions, should you wish. Absolutely, so.
So Todd, this is a question I had, I didn't get asked before. So the depth in the UT pool was 5 meters? Deepest depth. And what about the PT pool? And what about the deepest, cemetery hole, or is of you? So 25 feet or something?
Into the mic.
The comparison of the PT pool size to the other pools in the restoration reach that would be used for holding, so they have the depths that salmon target or cover throughout the summer holding period, are up to 7 times larger than the PT pool.
Yeah, so my question was, I was wondering about whether you saw the stratification breakdown each day, right? And so what I was wondering about was if the pool is bigger or deeper, would you expect the stratification to break down each day in that same way?
I would, and that is because as opposed to a lake where you have stratification form and persist through the summer period, that's a still water body. And it's not like a river, of course, where you've got the different temperatures being contributed to your pools between day and night. And to maintain that temperature gradient is to have a more constant temperature feeding your pool, but that's not the case of rivers.
Thank you.
Go ahead, Cal.
Yeah, this is really interesting discussion. I'm really enjoying it. I have a maybe not so well-formed question for all of you, but you've all worked in regulated rivers, and Bill Pinnock's presented yesterday, and he said he didn't include anything on steelhead, but I was an author on that report, and one of the findings was that we've actually seen a 60% increase in steelhead over the course of the program. So the pre-post, we saw an increase in steelhead. All of the salmon species declined by about half of what the steelhead increased by. So my question is, tailwater fisheries are famous for trout fishing. What are the implications of dam management on all of these regulated rivers that facilitate trout fishing and trout populations that are multi-year age structure, less dependent on a single recruit class compared to salmon rivers? Does anybody have any thoughts about our normal flow management below dams and why that would favor trout over salmon?
I agree that tailwater fisheries would favour rainbow trout, steelhead, and I don't know how long they stay in these rivers, how big they grow before they move up. There'll be a variety of sizes going out, I presume.
I think it's 1 to 4 years, and yeah.
Yeah, and so are they getting big enough to be actually eat juvenile salmon or not?
I don't think so. I think they mostly outmigrate before that. But we do have an interesting life history of steelhead on this river. It's called a half-pounder life history, where they migrate back into the mid-river one season after they went to the salt.
Yeah. Well, certainly the variable life history is going to favour them. And they also have can have higher velocity tolerances. So in the higher flows, they could probably do pretty well. So I really can't say a great deal more than that. I don't know enough about your rivers yet to talk really sensibly about that. So I'd sooner pass the question on to others and think about it.
So again, I've more experience with this kind of thing on Clear Creek than the Trinity, but again, a tailwater. And we have something interesting going on there. A lot of Omicus diversity, a lot. Our Omicus can be residents their whole life. They could go to the ocean as a smolt, come back as a steelhead, and then spend the rest of their life in Clear Creek. They can go out to the Sacramento River and then come back to Clear Creek to spawn. Every different thing. But unfortunately, our steelhead is probably around 5% of all Omicus. And I think, and this might be maybe too humanizing, but I think they're comfortable. If you're up in the upper watershed of Clear Creek where flows are stagnant and it's cold all the time and there's enough to eat-ish, right? They're good, they can make it. I think they're comfortable. What I like to see is more pressure put on certain locations where fry can grow really, really rapidly, and then things start to deteriorate for them, so they have to leave, stimulate migration. Because right now it's I don't think they have a lot of impetus to leave, and that's even though all the diversity is there. At some level, they're making a choice to not go. So whatever's happened on the Trinity that they are choosing to go, that's cool. That's great. And I think steelhead are extremely difficult nut to crack.
Well, I appreciate the response. It's obviously a question I'm pondering, and I study the rivers and am familiar with them and still haven't come up with an answer. But as you spoke about it, I started to think about life history diversity and how this really short time period is incredibly important to recruiting Chinook into the spawning population, getting them to the ocean, and how steelhead are just going to be more resilient over the course of the year. Maybe we get it right at some point, and that allows some to recruit in the population. Whereas Chinook, you really have to get it right at the right time of year to get them to recruit. So thank you.
Yeah, cool question. Nice answers. Eli, your findings show that discharge has the highest impact on temperature during April, May, and June throughout the Klamath Basin. Knowing this and the seasonal impacts of hypolimnetic release from Trinity Reservoir, how does it make you view the current flow management paradigm, which reserves all elevated flows above the baseline to essentially those 3 months that you identified?
Also, one thing that is, I forgot to mention when I was showing my slides earlier, all of the rivers that I was showing, I think, with the exception of the Fitzgerald spatial stream network models, but almost all of them were unregulated streams. So the relationship between flow and temperature in regulated streams is a lot more messier because, you know, some of them have cold water releases, some of them don't. Their hydrology is more managed. It doesn't really follow the natural pattern. So that's one thing. Another would be how does it make me? The question was, how does it make me feel about the thermal regime of the Trinity given those findings? I mean, I think it highlights that during those months. So Trinity Reservoir starts really cold, right? The water coming out of Lewiston. And so when we have high flows, if those are the months that flow has the most power, then it means those high flows can have a really powerful effect on the Rupert ecosystem. So I guess it means we need to be cautious and aware of how powerful those effects of the flow on the cold water can be my main comment.
Yeah, and just to clarify for myself, the initial thing you said is be careful taking those relationships from the Klamath Basin based on April, May, and June and applying it to regulated rivers. Is that the take home of what you initially just first said?
Yes, I haven't thought about it that much in the context of the regulated rivers and the cold water release versus not cold water release. So sort of implicit, and I think what is driving a lot of, but there are some, I'm sorry, I'm kind of mumbling and stumbling here, but so what high flow does is it moves water further before that water changes temperature. So in a natural unregulated system in mountains in the springtime, it's really snow melt driven runoff, right? So it's starting really cold, and then when there's high flows, that water can just get further and further downstream before it warms up. So at Trinity Dam and other cold water release reservoirs, the starting point is maybe not from snow melt, but it's accumulated, coldness, which, from the wintertime, it's a seasonal effect. So higher the flows are, the further it can make it downstream. If you had a regulated reservoir if you had a reservoir but it didn't have a cold water release, like on, say, Iron Gate on the Klamath, where it does stratify, but the releases is near the top of the reservoir because the water in the bottom is just nasty poison and would do really bad things to the river if they release it. So they release it from higher up. There, you don't see as much flow effect on temperature on the Klamath because it's not starting as a cold water system.
I don't know if there's any more questions from the audience here. We are wrapping up. I'm through my questions here. Well, I've got one more question that's testing 1, 2, 3, which I'm guessing, unless someone wants to answer that question, I don't think is one. So I think thank you very much for the panel. And with that, I'll turn it over to Kyle to wrap things up.
Yeah, we got about 4 minutes, but we can call it. That was a really good discussion. I want to thank all the presenters today and Andy for moderating. So give everybody a round. And we'll see you all tomorrow morning for day 3. We'll talk about the channel form, which kind of underpins everything that we've already discussed. And then I hope to see a lot of you on Friday for a field trip. Oh, we got one more question?
Yeah, since we have 4 minutes left, and that's, I'm sure, plenty. So I apologize for this question. I have 2 strikes against this. One, I'm not a scientist, and one, I was forced to miss this afternoon's presentation. But Todd, I did read your paper on related to Pear Tree Gulch in that area. And my impression of Pear Tree Gulch was that it's a place where there would be a lot of turbulence compared to some other pools. The water comes in there and it hits the wall, and you often see boils coming up there, and then it squeezes out not too long after that against the left edge. And so the question is, so that one showed 70 CFS as probably where it might stratify. Wouldn't there be a lot of other pools that would stratify at higher flows than that? And sorry if I missed your presentation, you talked about it.
It's fine. And yeah, you can ask a question anytime. I'll answer it because you successfully take us down the river every summer, so keep you happy. But absolutely, there's such a range in pool sizes, both in terms of depth and area, and in the bathymetry of those pools and how the pool water enters those pools relative where the depths are that springers would hold in. Yeah, there's going to be a distribution of different critical discharges for stratification. So again, back to the modeling exercise, it's going to be a matter of finding the sweet spots by time of year for what the discharge would need to be to provide the habitat across the restoration reach. It's not going to be a single discharge. It's going to be a number of discharges because different discharges will stratify different pools at different locations in the restoration reach. So putting that all together into a summer flow regime, I would expect that it'll be variable and higher than 70 CFS. We're modeling 15 pools, and then we're going to associate the findings in those pools to attributes of them to try to generalize the results for application across all pools in the restoration reach. If that doesn't work, yeah, we'll just model them all. Get her done.
Great question.
Thank you.
All right. Well, thanks for everything today, and we'll see you in the morning. And then, yeah, we have a field trip scheduled for Friday. Hope to see some of you there. So.